Welcome to lesson number 7. We're looking at geometric series now. So what happens when you have a geometric sequence and you add each of the terms from term 1 to Tn? We're going to be looking at two different formulas. Well, actually, it's really four different formulas that can be written in different ways. But this is the first one. I have the sum of my n terms is equal to a, which is term 1, times my common ratio to the nth power, minus 1, divided by my common ratio, minus 1. And keep in mind that the ratio, r, cannot equal 1, because then you're going to be dividing by 0. And so this is the same formula, but the only difference is a is substituted with t1. The second formula you're going to see is this one down here, which is the sum of your terms is equal to the common ratio multiplied by the term number minus term 1 divided by the ratio minus 1. And again, the ratio cannot equal 1 because you'll be dividing by 0 otherwise. So the first example we're just going to skip and we'll move on to the second one. So let's look at class example number 2. We want to determine the sum of the first 15 terms of the sequence. So the sequence I'm given is -5, 10, and -20. Looks like it's going up by 2 each time, being multiplied by -2. So a is equal to -5. r, -5 goes into 10, -2 times. 10 times -2 is -20, so my common ratio is -2. n is equal to 15, because we're told we want the first 15 terms. Now, if you're having difficulties finding the common ratio, remember that it's just t2 divided by t1. t2 divided by t1, which is 10 divided by -5, which equals -2. So we're going to use our first formula that we were given. So Sn is equal to a times my common ratio minus 1, all divided by r minus 1. So notice how we're looking for the sum of the first 15 terms, and I'm using this formula because I have all of these variables. So if I'm looking for S15, that's what n becomes. We substitute -5 in for a. My common ratio was -2. Notice how I'm using my brackets. N again was 15. We're subtracting 1. And be careful that you're not just subtracting 1 from 15, but from this statement here. It's -2 to the power of 15. And -2 divided by -1. So we can plug all this into our calculator, which is going to give us. And so sometimes it's best to do it in stages. I'll show you two different ways of calculating this. The first way, I'll just break it up into pieces and calculate it that way. So I started with -2 to the power of 15, then I subtracted 1, then I multiplied by -5, 6, and then what I'm going to do is I'm going to divide by -3. And that's our final answer. Now, if you're able to stay organized, excuse me, in your calculations, then you can do this all in one step. You just need to be careful with how you're using your brackets. So -5 multiplied by -2 to the power of 15 minus 1. And, I'm going to insert another bracket right here. Divide that all by, and in fact, you can use another bracket. And divide all that by -3. So we'll see if I was able to stay organized enough with all these brackets. Yes, I was. Okay, so you can also do it that way. but these brackets, the placement of these brackets is crucial. So just remember which operations are being carried out when. Alright, next question, determine the sum. In this case, this is a little different, this scenario here, because unlike the last example, we don't know how many terms there are. We know what our first term is, it's 4. Our common ratio, let's go term 2 divided by term 1. So negative 12 divided by 4, and we get negative 3 as our common ratio. And I have Tn, so I have my last term, which is negative 8,748. So we have to use a different formula for this one. This time we're going to use Sn is equal to my common ratio times Tn minus A divided by R minus 1. And so I'm still looking for the sum of my terms. So I'm looking for Sn still. My common ratio is negative 3. Tn was negative 8,748. And A was 4. I'm substituting all those in, and then I'm again dividing by my common ratio minus 1. So with these types of questions, because there's a little bit less happening, though exponents, we can do it all in one shot. And then, however, we still need to be able to, or we still need to use our brackets. Minus 4 divided by negative 4. So negative 6,560. So if I add up all the terms, they're going to equal this. Alright, so the sum of a certain number of terms in the series negative 2 plus 8 plus negative 32 plus is negative 104,858. What is the last term that would make this series add up to negative 104,858? Alright, so this time we're looking for the last term. So this is the sum we're given. And sometimes it's good just to say that just to write that. That's the sum. That's not one of the terms. So we're given term 1, which is A, and that's negative 2. Through that we can find the common difference. T2 divided by T1, so 8 divided by negative 2, we get negative 4. And we have the sum of our terms, which is negative 104,858. And we don't have the last term, Tn. And so what we need to do is we need to use a formula that has Tn in it. So we're actually going to use the one we just used, which was Sn is equal to R Tn minus A divided by R minus 1. And we can either simplify right away, or we can plug in our known variables and simplify as we go. So let's do that. Common ratio is negative 4. Tn is the term I don't have. A is negative 2. Divide all that by negative 4 minus 1. Negative 4 minus 1 is negative 5. Alright, so what I'm trying to do is I'm trying to solve for Tn. So the first thing I'm going to do is I'm going to multiply both of these sides by negative 5 to get rid of this negative 5. That is my denominator. So those cancel out, and we're going to be left with negative 5 times negative 104,858 equals negative 4 Tn minus, well, now it's plus 2. Alright, so let's move up here. Now I need to simplify that negative 5 and negative 104,858. So negative 5 times negative 104,858. I get 524,000 290 is equal to negative 4 times Tn plus 2. You can subtract that 2 from both sides of this equation. So I'm left with 5,204 290 minus 2 is equal to negative 4 times Tn. I don't know how I calculate that, but now to isolate that Tn, I need to divide both sides by negative 4. So divide that by negative 4, and divide that by negative 4. Those will cancel out. And Tn is equal to negative 131,072. So that's the term, that's the last term of this series. Excuse me. Alright, and number 5. In a sequence, the fifth term is, so T5 is 1,024, and the common ratio is 4. Find the sum of the first 7 terms of the sequence. So we want to find S7. Alright, well, first of all, there is something we're missing. We're missing our value of A, so term A. So first we need to find A. We don't know what that is yet. Now to find A, we're going to use our fifth term, so T5. So we know that T5 is going to be equal to A times R to the power of 4. N minus 1 in this case would be 4. But we know the value of T5, that's 1,024. So we can plug that in order to then only have one unknown variable, which would be A. So next thing we need to do, 4 to the power of 4, 1,024 is equal to A times 256. 4 to the power of 4 is 256. Now we got to divide both sides of this equation by 256, and we're given a value of A as 4. So A is equal to 4. So we need that in order to solve for S7. So we're going to use the first formula we used in this lesson, which was the sum of n terms is equal to A times R n minus 1 divided by R minus 1. And this time we're looking for S7. So our value of n is going to equal 7. 4 times 4 to the power of 7 minus 1 divided by 4 minus 1. So we can use I just did that all at once, but again, if you're not placing the brackets in the correct spot, then you're not going to get the correct answer. So if that's the case, I'd encourage you to calculate this in your calculator in steps. So the sum of the first 7 terms is going to be 21,844. Alright, so let's move on up to class example number 6. I probably won't end up doing all the examples in this video just so it doesn't end up being too long. So I might just explain which formulas you're supposed to use and how to use them. Alright, so for this one here, the sum of n terms of the series 5, 15, 45 is 16,400. Alright, so that's my sum of my n terms. Determine the number of the terms in the series by solving an equation with a common base. Alright, so I should probably do this one for sure. So A, first term is 5, R, 5, 15, 45, R is 3, and we're told Sn is 16,400. Alright, so we're going to be using the formula where we have our term 1 and our common ratio. However, this time we need to solve for n, for that exponent there. So we're told that this is 16,400. We're told a is 5, r is 3 to the power of n minus 1, divided by 3 minus 1 divided by 2. Alright, so the first thing I'm going to do is simplify this part of my equation. So that's 2. I have to bring this 2 up here, so I'm going to have to multiply both sides by 2. When I multiply this side by 2, it'll cancel out this 3 minus 1, which is 2. And then I got to simplify this side of my equation. So 2 times 16,400 is 32,800, and that is equal to 5 times 3 to the power n minus 1. Alright, so from here, I can divide my 5 out of my equation, and I have to do that first. I can't subtract right away. Alright, so divide 32,800 by 5, we get 6,560 is equal to 3n minus 1. Now I can get rid of that 1, so I'll add this 1 to both sides. So 6,560 plus 1 is going to give me 6,561. It gets canceled out over there, and that is equal to 3n. Alright, so now we have to find out what our common base is. So we want this to be a base of 3. So if we drop down that 3n, 6,561. So let's go 3 to the power of 6. Too small. So 3 to the power of 7. Still too small. 3 to the power of 8. 6,561. So guess and check is not the only way to do these. I'll show you later on how we solve for an unknown exponent. So n, if we get rid of those bases now, is equal to 8. The other way to do this is to use the intersect function in the calculator. So using the intersect function, all we would do is go 5 times 3 to the power of x, and we should really be using brackets here, minus 1 divided by 2. 16,400, and graph. So if this is what your graph looks like, you will definitely have to zoom out, because remember, y is crossing at 16,000. So that means that our y max we might need to set to like something crazy like 20,000, so we can actually see where this graph is crossing. So 16,000, yeah, it's going to be right about there. And our intersect function, you go second function trace, and then you choose option 5 for intersect, and then you need to kind of guess where you're going, where you're in between, and where that intersect is. And so our intersect is at x equals 8 here. Alright, this might be the last example that I'm going to do here. Well, I'll probably just walk through these ones kind of quickly. I don't want it to take too long. So a golf ball is dropped from the top of a building 100 meters above a paved road. In each bounce, the ball reaches a vertical height that's 3/4 the previous vertical heights. So what I'm going to do is I'm just going to outline the variables you need to use here. So the vertical height to the nearest tenth of a meter of the ball after the 7th bounce is what we need to determine. So we know what A is going to be. If the ball starts at 100, and in each bounce, and we're talking about the bounces here, not exactly where the ball starts. So after bounce 1, A is going to be equal to 100, where the ball rolls off. So if this is my building, this building is 100 meters. And then when my ball rolls off, hitting the ground from 100 meters up, it's going to bounce back up. This is, and it's only going to bounce up 3/4 the previous height. So it's only going to bounce up to right here. This is where that first bounce is, or term 1. Alright, so term 1 is actually not 100, it's actually 100 times 0.75, or 75. My value of R is going to be 3/4, 3/4, or 0.75. And the number of terms we're looking for at n equals 7, so n is going to equal 7. So just a little tip, the first thing we're going to have to do is find out what the value of T7 is. We're going to find T7. So in order to find T7, we have to plug it into this equation, AR n minus 1, where n minus 1 is going to be 6. Alright, so I'll let you plug in those variables to solve. And you're going to have to use this answer down here. So the total vertical distance to the nearest 10th traveled by the ball when it contacts the floor for the 7th time. So the first thing we talked about was the vertical height, but now we want to know the vertical distance. And so that's going to be the sum of those terms. And so again, A was equal to 75, R was equal to 3/4, and when it contacts the ground for the 7th time, so we're actually going to be talking about the 6th term here, n equals 6. And this time we're going to have to plug it into this formula. So you'll have to plug this into this formula. S6 is equal to A times R to the power of n minus 1 divided by R minus 1. This will get you your answer. If you, well, you have to add that to 100 at the end, just because that's where you were starting. Total vertical distance, right? Alright, let's do, then how many times does the ball travel? Or how many times does the ball need to bounce to travel approximately 675 meters in vertical distance? So this time you're just going to use that same equation we just used, but you're going to have Sn equal 675 this time. And so that's the only difference there. And then I'm gonna skip these ones for now, but if you are having difficulties with these, make sure you come see me in class, and I will help you with this example, as well as class example number 9. Just a hint for both of these. So for this example, all we're doing is plugging it into Sn is equal to, this formula here. So 5 times 3n minus 1. And we got to find each of the terms from this. So after we find that, we'll find term 1, term 2, term 3, term 4. But remember, this gives you sum 1, sum 2, sum 3, sum 4. And then for this question here, you're just plugging your variables into Sn is equal to A times R to the n minus 1 divided by R minus 1.